In this case, we're going to jump straight to the layout on the PCB board to cover the parasitics and the coupling. And so let me go ahead and open this project. Here is our antenna. You can see that there's a port here on the impedance side where you would put in your matching network and your port. And then over here, this is on the aperture side, and I'm going to start over here just because it's simpler. And I'll just cover, hopefully briefly, just an introduction. And in this case, we're using an aperture tuner, which is essentially a switch where we have the RF feed coming into the antenna, and this red box is just a cuboid with the faces set invisible, and we drew red lines for the edges. So that's all that we're visually rendering here, but it's supposed to represent the chip. So the chip has 3 pins. There's the RF connection to the antenna, and then this, there's a switch in here, which either we switch between the left side or the right side, and then that allows us to grab a component value. So this would be one of the loads that we're switching in or out, and then this would be the other load that we're switching in or out. And depending on what these switch state is within the aperture tuner, as well as the load values, we're essentially changing the input impedance of the antenna that we would see from this port, right? So if we're looking at the input impedance from this port over here looking into the antenna, that input impedance is going to change depending on the switch states and the loads that are seen over here. And so, if you think about smartphones these days, they've got many bands that need to be supported. And instead of making this antenna longer or shorter, which we can't do once the phone's manufactured, we can use a software controlled capability to change its input impedance. On the input side of things, we have a much larger tuner. Again, this is just represented in blue, so you can see which terminals are inside the impedance tuner and then which ones are outside. There's multiple ports here that are outside the impedance tuner that are allowing us to switch different values in and out. The impedance tuner itself has 5 switches within it, as well as 2 capacitor banks. And so in total, there's 25 ports here within the full wave simulation. We created a response matrix, ran the simulation, got the 25 port matrix, and then we were able to bring that into the schematic and build this all out. So this is the 25 port FDTD simulation that we have. Some of those ports are connected to the fixed component values, those inductors or capacitors that are outside of and then we have the tuners represented. This would be the impedance tuner, this would be the aperture tuner. And in order to just introduce sub-circuits and talk about this in a little bit more detail, I have a different schematic here where we're just going to talk about the tuners themselves. So looking at our impedance tuner, we can see that, yep, there are 5 switches as we go around, and then there's 2 capacitor banks that are available. This text up here is just showing us what are the states of all of those values, and I can double click on this. This will open up the editor. So we have the 2 capacitor banks with all of those values available. We have the switches, which are essentially on or off. And then depending on the state or the values of the switches and the capacitors, we'll have these registers as well as the tune code. So if I, right now the tune code is 1110. If I switch this from on to off, well then the tune code dynamically updates as well as the register dynamically updated. If I had a tune code like that my colleague provided and they said, hey, plug in a new tune code, well then you can just copy and paste that tune code into here, and your switches and capacitors will update accordingly. Well, if I wanted to right click on this schematic, I could enter it and I could go into the subcircuit and I could see how all the different terminals are laid out and the different SMP blocks that were imported. We don't need to do that. Just be aware that you can obviously enter and exit your subcircuit and actually see the contents of it. But from a consumer, from the parent level schematic, this is primarily what you're interested in, right? What are the values of each of the components that are in my schematic? And you'll notice here that we have a nice symbol. It's representative, so that way you can see, oh, all right, well, this terminal goes with switch 4, this terminal goes with ground. And this is a custom symbol that has been entered. If I just move over here to the left, we can see that this would be the default symbol. So this is just showing you what are the names of all of the terminals, but there's no graphic graphical representation. So with our subcircuits, and really all of our circuits, you can right click on it, you can come into the symbol, and you can edit the custom symbol. And so this allows you to bring in the image as well as define text and produce something that's more user-friendly. So this is what we have for the impedance tuner, and then something similar for the aperture tuner. And this might make a little bit more sense now that you're seeing it. This would be the terminal that went to the antenna, and this would be a terminal that goes to one of the loads, and then the second load. And so here, this is just what the schematic looks like with all of that applied.